pocket-tts is a lightweight text-to-speech application that runs efficiently on CPUs. Forget the hassle of GPUs or web APIs for TDS models. With kyutai-labs pocket-tts, generating audio is just a pip install and a function call away. It supports Python versions 3.10 through 3.14 and requires PyTorch 2.5 or newer, but it does not need the GPU version of PyTorch. The main takeaways are that it runs on a CPU, uses a small 100 million parameter model, streams audio, has low latency, about 200 milliseconds to get the first chunk, and can run faster than real-time on a modern MacBook Air M4, about 6 times real-time. It uses only 2 CPU cores, has a Python API and a command line interface, supports voice cloning, and works in multiple languages including English, French, German, Portuguese, Italian, and Spanish. It can handle infinitely long text inputs and can even run in the browser on the client side. If you want to try it without installing anything, just go to the kyutai website and type in some text, pick a voice, and hit generate. If you prefer a command line approach, start with a generate command. The recommended way is to use the tool called dev, which installs any dependencies on the fly in an isolated environment. You can also install with pip. The basic command creates a WAV file called tts output wav with the default text and voice, and prints speed statistics. Bash uvx pocket-tts generate, or, if installed with pip pocket-tts generate, you can change the voice with a voice flag and the text with a text flag. A list of pre-made voices is provided, such as Alba, Giovanni, Lola, and many others. For non-English languages you can choose a higher quality 24-layer variant, for example, language Italian 24L. The config option accepts only a local YAML file for custom weights. The serve command launches a local server that you can hit with HTTP requests or use a small web interface at localhost 8000. It stays in memory, so subsequent requests are faster. If you plan to do voice cloning, the export voice command converts an audio file to a fast-load Tensors representation. The conversion takes a while, but loading the Tensors file is very quick. You can use pocket-tts as a normal Python library. Install it first with pip or uv, then load the model, get a voice state, and generate audio. For example, Python from pocket-tts import tts model import cypio-wav file. tts model equals tts model load model. Voice state equals tts model get state for audio prompt alba or any voice file or Hugging Face link audio equals tts model generate audio voice state. Hello world, this is a test. cypio-wav file write output wav, tts model sample rate, audio numpy. You can also export a voice state to a Tensors file to load quickly later. The API documentation on the website shows more detailed examples. Currently, pocket-tts does not support adding silence in the text input to generate pauses, but this could be added via a pull request. The model was also tried on a GPU and showed no speed advantage over CPU due to its small size and batch size of 1. Development is open source. You can contribute via GitHub, read the contributing guide, or run tests in linting locally. Pocket-tts can run in the browser using WebAssembly or JavaScript. No official support yet, but community projects exist. Was pocket-tts by Laurent Mezer, pocket-tts onx export by Kevin H., Candle version by Bababirdbird, and Jaxjaz by Xhang, among others. Alternative implementations and ports exist for different backends and languages. Pocket-tts MLX for Apple Silicon, pocket-tts XN is a Rust port with XN, pocket-tts Candle, pocket-tts CPP for C++ with ONNX runtime, Sherpa bindings for 12 languages, and a C port. Many projects use pocket-tts, a browser screen reader, a Docker container for Home Assistant voice, a mod for Hogwarts Legacy, native Mac OS and Electron apps, an OpenAI-compatible streaming server, Unity integration, Comfy UI plugin, Discord text-to-speech bot, and many others. Use of the model must follow all applicable laws and not be used for malicious purposes such as voice impersonation without consent, misinformation, or hate speech. The authors explicitly disclaim liability for non-compliant use. The model was created by Manu Orsini, Simon Roward, Gabriel de Marmies, Václav Valhejn, Niels Egeder, and Alexander de Fosses, with shared contribution.